Welcome to the RPS project. I'm Richard and today I'm going to be having a quick look at the common emitter, common collector and common base circuits. Three very simple circuits for an NPN transistor. I just feel I need to know a bit more about the signal path through these circuits and how to get an effective amplification out of them for use in a larger circuit, especially in an audio circuit where this might be the initial first stage amplification. So let's have a look at the common emitter first. So here we have the common emitter circuit that I'm going to be using. I've kept it as simple as I can. NPN transistor, probably going to be a BC337, 10k and 3k3, so I've got about 1.6 volts on the base, so I know it's turned on, it's in the active region, and output is 1k on the collector, 470 ohm on the emitter. So my output from this is coming into the base and out on the collector, and this gain on here is a function of these two resistors. So I'm expecting sort of twice, rub that out, I'm going to draw that 2 on there again, 2, so I'm expecting twice the gain. So whatever I get on the input, I'm expecting the output to be twice that on this basic common emitter amplifier circuit. So I say extremely simple, extremely basic, but I want to see it in operation so I can know that I'm doing it right. I've got the circuit set up correctly and I understand how that has been set up. So let's get and look at that on the workbench, eh? So here we have my circuit on the breadboard. Only a little circuit, did a little thing, can't see too much. Biasing for the use my pointing stick, biasing for the base up here, collector, emitter, bit of capacitance on the voltage input, BC337, scope on the input. So this is my input from my signal generator over there, over that way, and I've got the scope over there as well. I'm going to pan over to them in a moment and we'll have a look at it once I turn it on, and my output is here. So that's it. It's a really simple circuit, seen the diagram, so just going to pan on over to the function generator so you can see what I'm putting into this. Just to get that across and up a little bit. And what have I got on the display? As you can see, that is 1 kilohertz, 200 millivolts. So nothing spectacular. I'm not putting in a big signal. So let's have a look and see what we get out. So I'm just going to pan up again and focus on the scope so we can see what we're going to be getting out from it. There we go. So now we can see what we're gonna get. So let's turn this on. I think I'll turn the signal on first. And as you can see, it's wobbling about all over the place because I've got the trigger set to channel 2, but that'll come apparent once I turn the circuit on. 5 volts. And there you go. What have we got? Well, as you can see, this is set to 100 millivolts per division, so 100, 200 on my input. That's brilliant. And on my output, I've got 100, 200, 300, 400, just over 400 millivolts. So that's double the input, which is exactly what I expected. Double the input, and it's inverted because this is what the common emitter will do. It will invert the signal, so it's 108 degrees out of phase. Brilliant. If I just invert that, it's inverted. If I back to normal, inverts off. That's brilliant. That's exactly what I'm expecting. No ifs or buts, no faffing around. Yeah, brilliant. Can't say more than that, can I? I've actually done it very simple. I've kept the circuit as simple as I possibly can, and as you can see, low voltage. And if I turn down the amplitude, down to nothing, down, they both go up and down together, you know. So it's always the same, which is brilliant. So that's the common emitter circuit. Very simple. So let's move on and have a quick look at the common collector circuit. So here we have the common collector. Only difference here on this circuit, exactly the same as the common emitter, except I'm taking the output from this point here at the emitter. Input on the base, everything else is exactly the same. Now the difference with this one is I expect to get a unity gain. I'm not going to gain anything. The voltage output will be the same as what I put in. So if I put 100 milliamps in, sorry, 100 millivolts in, I will get 100 millivolts out. 100 millivolts. I'll get there. Obviously with this circuit I will get a much greater gain on the current on this circuit. So that's where this circuit is as it were gains over the common emitter. I get same voltage but a greater current through it, which is brilliant, with nothing else changed except for where it comes out on the output. So let's have a look at that on the bench. So here we go. Now we've got my common collector where my input is going in on the base but is coming out on the emitter. So I should have unity gain on this. I've still got exactly the same setup as far as before. 200 milliamps, 1 kilohertz, sorry. So if I turn the channel on, sorry, it's a bit wobbly, it's not triggering on 1, it's triggering on channel 2. So as soon as I turn this on with 5 volts, it should become stable. And there we go. One is directly over the other. So let's just shift that down. As you can see, they're exactly the same gain. There's no additional gain. What I get in is what I get out. And it's in phase, which is brilliant. So that's a very simple setup. All I've done is taken my output from the emitter and shifted it to the collector. It's as simple as that. Sorry, the other way around, isn't it? I've taken it from the collector and now take my output from the emitter. So must get these emitter and collectors the right way around. So I know what I'm dealing with. So yeah, so that's all you get is what you put in, it's what you get out. But you also get a lot more current from this. I haven't got the multimeter on there to check that, but if I had a load I could certainly do that. But there you go. What you put in is what you get out on a common collector. Marvellous. So let's have a look at the last circuit, which is the common base, which is a little bit different, or as far as I can see looks a bit different. So let's have a look at that then. And now for the common base. Now this one's a little bit different, but because we have the input here on the emitter, sorry, on the emitter, and the output on the collector, and the base we're just biasing up to get it turned on. But we do have this this electrolytic over here, and I take it that with a capacitor there, it's probably going to raise this voltage above that 1.6 volts. So I'll have to take a measurement, I think, and have a look at what the voltage is on the base to determine what I'm getting there, so I know how much this transistor is being turned on. But the thing about this one is it can take a very small signal and amplify it quite a bit, so lots of gain. But how much gain? It's supposedly a lot more gain. It's not just a factor of that divided by that. I'm going to get a lot more gain than that. Input through an electrolytic. All my outputs, as you've been seeing, are going out through another capacitor, just so I take off the DC bias or any DC bias that might be in there. But other than that, the rest of the circuit is the same, so I'm not really changing a lot. All I've been changing is where it goes in and then comes out. Well, effectively on the first two, the input was the same and the output changed, but on this one I'm changing where the input goes in. So let's have a look at that on the bench, eh? So now I've got this set up on the common base, which you know, it's right, it's out of shot, but I do want to get the scope as the main attraction on this, so I can see what we're getting out. Breadboard setup's pretty simple, exactly the same as before. I know we're getting the input is coming in on the emitter, and the output is from my collector. So 200 millivolts, 1 kilohertz. Let's turn this on. Let's turn the signal on, and again it's being triggered on channel 2, so it will come steady. And turn this on, 5 volts. Whoa, you look at that. That is huge. That's amazing. I wonder what the voltage is on the base, because I was going to have a look at that, find out what the voltage on that base is. I know it's going to be out of shot, but I will tell you. I have got, let's have a look, 1.23 volts. So it's not like huge, but it's just normal voltage I'd expect to have on there. So the transistor turns on. You might notice though that the input is being dragged down. It's been I forgot what you call it now. It's mad. It's being reduced because apparently on this circuit it's a low impedance input, so it will load down the input of whatever I put in there. Let's see if I can turn this down. This is at 500 millivolts, right? And the input is on 100 millivolts. So let's turn that the other way, 50 millivolts. So I've got about 100 millivolts. Really noisy, really noisy. That's terrible. But the output looks quite clean. What have I got there? I've got, it's on 500 millivolts, so that's 1 volt, 2 volts, about 2.5 volts, 2.6 volts, something like that. So from my 200 millivolts input, I'm getting about 2.6 volts output. That's huge. That's a really large amount. I wonder if I can get the cursors on that. What's that on? Channel 2. Voltage. See if I can get a measurement on that. About there. 2.56 volts. So yeah, that's a lot of gain, isn't it? You know, from like 200 millivolts. Let's just change that to channel 1. And I know the signal is really fuzzy, so there's a lot of noise in there on the input, but never mind. At least we get an idea of what we're putting in. 104 millivolts. Yeah, 100 millivolts and 2.5 volts output. That's a massive gain. So this circuit really has a lot of gain in there. So that's brilliant. I really like that, having that much gain in a circuit. Obviously I wonder how much or how small can I get the input, because obviously this is a huge amount of gain. So I mean, if I've got less than, let's just take this down. I've got, that's 100 millivolts. That signal is so awful. That's just terrible. That's 90. Let's go down to 50 millivolts. Let's change the scale on these. Oh, let's go the other way. That's it. Turn this one up. Man, that's it. I don't know how I'm going to clean that input signal. It's just horrendous. How can I clean that? That was just not good at all, is it? Let's see if I can get these connections a bit wobbling around a bit. It's like spaghetti junction again. Well, a little bit better. Let's see if I put it in a different socket there. Well, let's get some more leads. Hang on a minute. See if I can get something a bit more tidy from this, from these connectors, because that is hellish noisy. Oh, come on. no, everything's going Pete Tong now. Well, that's okay. That's looking better than it was. So back to having a look at this scope. Sorry about the messing about there. I've now changed the scale. I've got 10 milliamps per division. So I'm only, according to this, even though it's being loaded down, I've got 50 milliamps on the input from this. Millivolts, sorry, 50 millivolts. But it's shown here that I'm getting 10, 20 millivolts. But my gain, this is 100 millivolts. So 1, 2, 3, 4, 5, 6. 650 millivolts. So the gain is just huge. I'm just going to turn this down a bit more. Let's turn it all the way down to something like 10 millivolts. Let's turn these up. Oh, look at that. Oh my goodness me. No, I think I have to turn it up slightly because it's yeah, it just gets too noisy, doesn't it? Too much noise. So back up to that 50 millivolts. Turn these to, well, not the frequency, don't want to do that. Turn that to 10 millivolts, and that's 100 millivolts. Yeah, that's enough fanning around, isn't it, with that? But you can see quite clearly you get huge gain from the common base amplifier compared to the others. But it does load down this input signal quite a bit. I've got an input of 50 millivolts, but on here it's only 20 millivolts, so it does load it down. I suppose you could take the circuit and have something else as its input that has an high impedance output, one of the other two circuits, sorry. I don't know if that would work. I'd have to have a look at it and see if that happens. And the other one would be if this feeds into another circuit, again, I'd have to have a look at that. But for me, yeah, that works. I'm happy. Brilliant. So there you have it. 3 circuits that all work as well as I expect them to work. The common emitter, common collector and common base. All very simple circuits, but I felt that I really had to understand them a bit better. All I've had to look at them previously was multimeters. So having the equipment that I've got now helped me to really understand those circuits a lot better. So yeah, that's quite great. I mean, you can also use them in combinations, such as the Emitter Follower, which is basically a common emitter with the output going into a common collector. So what you have there is a first stage amplification that amplifies the voltage more than the current. You get some current gain in there. You're going to get so much against what you put in on the base. But then the common collector has a much higher gain, but it's unity on the voltage. So you can, once you've got the voltage gain you want, you can get additional gain from the current and be able to drive something that needs a bit more grunt, a bit more power in there. So like a speaker or something, which is brilliant. So I presume you could probably use the other circuits, all 3 of them, in different combinations, so that you can get a different output, a different signal, that whatever it is that you're trying to control at the end there. So yeah, combinations. I'll have to have a look at that. Anyway, I'd also like to give a thanks to Alan from the W2AEW channel. I've actually been watching his videos, and I think that's where I've learned quite a bit of stuff about what I'm trying to learn. But his videos are tutorials, whereas my video is just me trying to learn the stuff. But he's brilliant. He really knows his stuff. So head over to his channel. I'm sure it'll be entertaining and very, very knowledgeable. So there you go. I think that's it. I think I've learnt as much as I can in this video. So anyway, if you didn't like this video, give me a thumbs down. If you did, give me a thumbs up, subscribe, and all comments are welcome. And I'll see you next time.